without any delay, I will get started. We've got a lot of things to cover in this discussion. But while there is shortage of, I would encourage each one of you to ask questions as and when they come to your mind contextually. Don't keep your questions to the end. But if you prefer to keep your questions to the end, it's also fine. But let's try and make this, interactive. So, this is a 2-hour discussion where I will talk about smart contracts. I will talk about how smart contracts and IoT applications are built using blockchain technology. Right. I'm assuming that you all have, had some overview of blockchain. But what I'll do is to kind of set the context right. I quickly recap on blockchain technology before we get into smart contracts. So from what you've already learned so far, or what you've heard from other participants and other speakers, you know that blockchain is, a distributed ledger technology. It is secure, it is unanimous, it is timestamped, it is distributed, it is immutable. Correct. Now, if you look at the bottom part of it, it very highly shows how actually a blockchain transaction is written to the blockchain network, right? So there is a transaction, then a block of transactions is formed, somebody verifies the transaction, somebody solves a mathematical challenge, which is called the nonce, right? Once the challenge is solved, it is broadcasted to the network. And once it is broadcasted to the network, other miners can actually verify that the challenge was correctly solved. And the block is added and the miner gets the mining reward. So that is typically how a blockchain transaction or a blockchain works. The idea of putting blocks together and chaining them together is called blockchain, really speaking. Right? Now, one of the important things in blockchain is also smart contracts. Correct. And typically, this is where the enhancement of blockchain solutions come, because while we can understand that transactions can be mined and transactions can be validated and transactions can be loaded into the block and connected to the chain, we need some ability to kind of implement some type of business logic, right? And this business logic or business rules, if you might sometimes call them, is something that is actually implemented by smart contracts. In our discussion today, for the rest of the time, we will be talking about smart contracts. We will talk about the genesis. We'll talk about how it works. We'll talk about what are the different types of smart contracts. Eventually, ending into saying that how does IoT get used in this? And at the end, there are a couple of use cases that I want to explain to you so that you understand the application of smart contracts and the application of blockchain in the real world, actually. So moving on, let me talk about the genesis of smart contracts. So how did the concept of smart contract really come up, actually? Right? When did it come up? Why was it come up? Why did it come up? We'll talk about that just now, right? So the term smart contract was first coined in 1994 by a software engineer or a computer engineer called Nick Szabo, actually. And this is long before Bitcoin was actually invented. His idea at that point of time was to come up with a transaction protocol, which is completely computerized in the sense that it works on business rules that are defined, and the business rules are executed by the computer instead of humans, basically. And so it is supposed to be automatic in nature. Now, the term smart contract could be a little bit misleading. Sometimes we start thinking that these are smart applications like, AI or machine learning. And sometimes you also start believing that these are contracts as we know them outside in the world, basically. But, I leave that misunderstanding aside. But, the idea is that a smart contract is more of a program or a programming language, if I might call, right? Now, why was it required? Now, Bitcoin on blockchain has got some scripting language, right? That scripting language allows you to write some scripts. It can allow you to put some commands on a stack, and the commands will get executed, right? The problem, however, is that it only has commands. does not have Turing completeness. With Turing completeness, we mean that a programming language which allows to write a loop, which allows to write functions, which allows to do decisions, basically. That Turing completeness is actually incomplete as far as Bitcoin stack-based scripting language is concerned, right? On the top of it, what happened in 2013 is that Vitalik Buterin proposed Ethereum, basically. Ethereum is the second largest cryptocurrency today in the world, actually, after Bitcoin, right? He decided to kind of innovate on top of the scripting language, and he introduced the word smart contract again in the Ethereum virtual machine. Now, what it really means is that Ethereum runs its virtual machine. That virtual machine has capability to kind of execute code that is given in the smart contract. And above all, the smart contract code is Turing complete, which means that I can do if else, I can run a loop, I can say if the date is so and so, do so and so, those kind of things. I can say if the date is more than let's say some date, then this is invalid, and these kind of functions and rules. And we'll talk about, I'll show you some examples of rules later. But the idea is that the Turing completeness of the scripting language is very, very important for the smart contract. Now, the typical thing about smart contract is that while it is still a software program, okay, it runs in a specific environment, and that specific environment is the virtual machine, the Ethereum virtual machine. You cannot take the smart contract and start running it in, let's say, a Java Node.js server or stuff like this, basically, or even in a Java interpreter, right? So the point is that it runs at a specific target. The specific target really is the Ethereum virtual. All right. Going forward, actually, right? Now, what is the ability of that smart contract? What does it do to smart contract? First of all, it makes the blockchain program, right? So basically it is allowing me now to basically do state management. It allows me to kind of build business logic. It allows me to interface with the external data, basically, right? The external data, which is very necessary. Think about a business application, right? Think about an application where you know a particular consignment truck is entering a gate of a factory or a warehouse, and an event is raised. Now that event is raised outside blockchain. There has to be a mechanism for the blockchain to kind of work with that data, because there could be a smart contract inside the Ethereum network which executes uh, payment, let's say, for example, because the goods have been received, right? Now that requires a mechanism for the blockchain platform to access the external data, right? Now that the programmability basically then transforms the capability of blockchain by many fold, because now you can do many things than just transferring money, correct? The other thing it does is it allows you to basically come up with something called programmable money. Money, as we know today, basically is something that I give it to you, or you give it to someone else, or you basically pay to the shopkeeper, and he gives you some goods, right? There is no programmability. Let's say, take an example of royalty. If you are an author and you wrote a book, let's say, for example, then when the book is sold, right, somebody has to say that, okay, the book is sold. Somebody's doing accounting, has to find out what is your royalty percentage, and then basically transfer that royalty to you, right? Now with smart contracts, this thing can become automatic. You can potentially offer a digital asset. If it is being sent from one place to the other place, you can build rules in that on saying that when the custody changes for the asset, then at that point of time, some amount of money as well should go to some third account, actually, right? Let's assume I created for simplicity's sake, let's say I created a digital book, right? And the digital book is accessible through a smart contract, let's say, for example. Every time somebody buys the digital book, let's say, for example, it is sold for 100 rupees, I can program over there saying that 10 rupees should come to me, basically, right? And that ability to now automate things, or even micropayments based on rules, let's say, for example, right? That ability is something we call programmable money, which is made possible today by uh, by smart contracts, basically. Okay? So that is the other big advantage of smart contracts. If you were to basically count, the benefits of smart contracts. Okay? Now I'll pause here and see, whether there are questions around smart contract or the genesis of smart contract or the function of smart contract, because at some point of time you need to grasp a little bit more. Uh, and if you have a question just now, feel free to ask. I'll wait for 30 seconds or else I'll continue.
Yes, sir. Yes, hello. Good morning, sir.
Go. Good morning.
Yes, sir. And you are talking about the smart contracts, right?
Yes.
Can we call this smart contract will work as a consensus?
Consensus is slightly different. Smart contract is not really a consensus. Consensus would be a separate activity.
Yes,
Consensus
sir.
is a mechanism to say that everybody agrees to a particular transaction, basically, right?
Okay. Okay,
Here
sir.
you can think that this is executed by business rules, which is some kind of consensus. If I say that if the truck enters my warehouse before 12 noon on 26th of August, then
Okay.
it is a valid consignment, basically, right? So that is also a kind of consensus, but this is not specifically consensus.
Yes, sir. I have the problem is I need a small clarity, sir. I'm confused with
Okay,
the topics what I have studied earlier.
okay.
The thing is, we have consensus by using the miners in the cryptocurrency point of view. Say, for example, if I'm using the same blockchain for any other commercial use, say, for example, if I'm implementing the same blockchain for some supply chain,
Mhm.
at that places, if I wanted to make a consensus, can I use this smart contracts as a consensus for that?
In combination of something called validators, yes, basically. So you are talking
Okay.
about Ethereum or Bitcoin, let's say, for example, but
Uh,
Ethereum or Bitcoin is not your best example for a supply chain solution. So let's
yes.
assume that, I will talk about Hyperledger a little later, basically. Let's assume Hyperledger, which is again a blockchain platform. It's an enterprise blockchain platform.
Okay.
One thing important to understand from a blockchain perspective, that there are two types of blockchains. One is
Yes.
the public blockchain. This is Bitcoin, Litecoin, Ethereum,
Yes.
XRP, and all those things. Then there is a private or permissioned blockchain, or an enterprise blockchain, as we call it sometimes,
Hmm.
which are platforms like Hyperledger, or platforms like Coda, or platforms like Cora. Here, the difference between these two is in the public blockchain, you are unaware of the participants. That is why trust has to be engineered through consensus or through mining, basically. In
Okay.
case of an
Okay.
enterprise platform, you already know the participants. You know that you are dealing with company XYZ in the US, company ABC in Japan, and there are several banks in India. So all these participants are known to you. What happens in a private blockchain is that uh, proof of work or mining, as you understand, does not happen. There is a concept called validators, or a concept called voting, basis which a transaction consensus is arrived at, basically. So in a private blockchain, you can use smart contracts in combination of validation and voting, and then say that the consensus has arrived at.
Thank you very much for your great explanation, sir. Thank you very much.
Okay. All right. Thank you. But a great
Thank
question. I think so. That is a question that a lot of people have in mind. It is.
you.
I
Yes.
can understand it is confusing,
Yes, sir.
but let's try and make this a little simpler. All right.
Sure, sir.
Moving on.
Thank you.
Now let's talk about smart contracts on the Ethereum platform. Since smart contracts were invented on Ethereum, let's talk about them on the Ethereum platform. Right. So let's see what happens. So what is the Ethereum platform? Ethereum platform is a blockchain-based platform, right? It provides globally disintermediated value for value exchange. So fundamentally, today you can actually send ethers from your wallet to somebody else, anywhere else in the world, irrespective of who that person is. So long as basically you agree that some exchange has to happen. That is what Ethereum is. That is what blockchain also is. In fact, that is what all the public blockchain platforms, right? Now, uh, uh, but there is a difference, basically, right? Blockchain, Litecoin, and some others will allow you to send and receive crypto transactions. It can do more than just, but Ethereum can do more than just transactions. Like I said, right? The capability or the value of Ethereum gets enhanced because of the smart contract concept that is brought. Right? The Ethereum platform, okay, is also a token framework. Token framework means you can actually create your own tokens. So Bitcoin is a token, Litecoin is a token, Ether is also a token. Think about a situation where you want to create a token of it, right? Let's assume that you wanted to set up a closed loop system where you issue tokens to participants, and participants can exchange tokens for, let's say, some facility on the campus, right? Let's say food, let's say library access, let's say book access, whatever, right? They can use this. Now, for this, you obviously cannot use Ethereum or Bitcoin or Litecoin. You would want to create your own token. And Ethereum allows you to do that. Okay. And because of that, today, this Ethereum is a platform of choice for something called DeFi. It's called decentralized finance. The DeFi ecosystem, okay, allows you to kind of have financial transactions happen between people without the need of intermediaries, basically. So there are two types of finances, basically. The traditional financial system. The traditional financial system is available, which is an intermediary, basically. In a DeFi system, there is no intermediary. There is only two people transacting with each other and bunch of smart contracts which make it possible to kind of do transactions. For example, I'll quickly give you an example of one of the DeFi platforms. There is a platform called DAO, Compound, actually, which allows you to stake your Bitcoin to some protocol. Then you get interest on that. Correct. Now that is all. How would you ever get interest on that? That interest would have got to you if your staked coins were lent to somebody and that person was paying interest to the system. All of this is automatically managed. You're staking, somebody taking a loan, that guy paying back the interest being calculated for you, being shared to you. All of this is happening through a smart contract, actually. And there is no human interaction in this space. There is nobody sitting and saying, Agnello has put 10 Bitcoins, and because of his 10 Bitcoins, he should get 1 Bitcoin as interest because that is 10%. That is not happening. That is all happening automatically. The Ethereum platform today is the platform of choice for DeFi. Not to say that there are no other DeFi platforms. There are two other DeFi platforms which are used, but the largest chunk of DeFi solutions today are on Ethereum, right? So it is composed of some key components. I spoke about the Ethereum virtual machine. The Ethereum virtual machine is the target. Where the smart contract actually compiles and executes. Think of EVM as the Java virtual machine. When you write your Java code, right, you compile it to a particular target. That target is Java on Windows or Java on Linux, Java on Unix, Java on Solaris, wherever that is. But you are compiling it to a specific virtual machine, the Java virtual machine. And Ethereum is something like this, because the code that you write, or the smart contract code that you write, is compiled and deployed on the virtual machine, on the Ethereum virtual machine, right? It is a distributed ledger, right? It's a decentralized ledger, so it typically holds the transactions and the smart contract on the disk, basically, right? Basically, the smart contract is a record in the ledger, really speaking, right? It is driven by consensus, proof of work, moving to proof of authority or proof of stake, basically. Right now, Ethereum is doing proof of work, but we did earlier this month we did the London release, actually, which moves one step closer to something called proof of stake. And the proof of work one day will go away by the end of this year, and you will only have proof of stake. So there is no heavy mining, there is no lot of power requirement. All that will kind of go away. And then it is innovated by smart contracts, as I spoke earlier. And Ether is the native token. So these are the core components of an Ethereum system, basically, which make the Ethereum system what it is today, basically. All right. So what is a smart contract? I've said it earlier. It's a set of conditions that need to get satisfied for a transaction to get complete, right? between two parties, three parties, or multiple parties, doesn't matter. Automatic enforcement of conditions. I said earlier that this is a particular event, something that happens. Right? The truck coming into the gate is one example. If you go to the financial space, let's say in the stock market phase, then there are futures and options basically. Right? The future contract is a forward dated contract. On the date of the contract, it will get executed. Basically, that is another. Right? And it has got the ability to kind of execute a transaction without an intermediary, because it is now not waiting for someone to come and click a button on the workflow and say approve. Sorry, there's a question.
This speaker is very good, sir.
Sorry.
It's very good, sir. Thank you. Same.
Am I audible?
Data science.
Hello.
You are audible, sir. You are audible.
Okay. There is some background noise.
Somebody is asking some question, but participant, your voice is not clear. Please be louder.
Let me check. You want me to check your name, right?
I think somebody is having a side discussion. So maybe we'll continue. It's not a question, I think. Basically. Okay. So smart contracts, are a crucial component for a blockchain or a data platform between two parties. Right? It is, like I said, right? Without smart contracts, you potentially are not able to kind of build a true business application. But because a true business application has got a millions of business rules basically, and those business rules need a way to get executed. That way of execution requires that some platform provides a Turing completeness of programming. This is what Ethereum provides, and so smart contracts are kind of executing in the manner that business rules can be executed. It is a decentralized paradigm, which means that it is kind of executing without the authority of a centralized system. And just like the data, the code too is replicated on the network. So just like the transactions are replicated across all the nodes in the network, the smart contract code also is basically. And smart contracts are basically written in a programming language called Solidity. I'll talk about Solidity a little later after this. But Solidity is the programming language. There are other ways to kind of code. There are multiple other ways, but Solidity is the original mechanism. For example, you can do this in Python also, and they can do this in Java also. Solidity is a JavaScript kind of a language that we will talk about just now. So what is the Solidity programming? Right? It was the core contribution from Ethereum when it started building, because when they started building the virtual machine, right, there was a need to basically have a language which the virtual machine could understand and interpret, right? So it's a contract oriented language. You write code implementing smart contract that runs on the Ethereum virtual machine. So it's got a Solidity compiler which compiles the code and then executes the code, the instructions in the code basically. Again, since it is non-intermediated, it basically is self-enforcing business rules, and it kind of executes the business rules based on events that are happening. It does not require a human interaction to come and say, do this now, do that now. Whatever is coded as business rules, those business rule events are generated and get executed. Solidity is similar to JavaScript. So if you already know JavaScript, then Solidity is very, very easy for you to pick up. Even if you don't know, JavaScript itself is an easier language. So understanding the syntax and writing the Solidity code is not a difficult task, right? It supports object-oriented features like most of them support, but also supports enums, data types, arrays and operators, and many more things basically. And like I said earlier, Solidity is a fully Turing complete programming language, which means that it is no different from, let's say, a Java programming language that you might be using, or Golang that you might be using, Python that you might be using, or Rust you might be using. It is at par with all of these, along with the support for the OOPS features and the different data types and operators that it provides. Right? So Solidity is your program. Now Ethereum platform provides smart contracts. Smart contracts are written in Solidity. They allow you to basically define business rules, and that's what you really want from a blockchain perspective. Actually, there is a question which flashed just now. If you can repeat that question, I can answer because I am not able to see the chat window at this point of time. If you can speak out the question, I can give you the answer for that. Okay, we can pick it up later when you come across this. Please feel free to ask the question again. Now let's look, how does the Web3 interface for smart contract? What is a Web3 interface? A Web3 interface is basically something that allows your external application to interact with the smart contracts. Remember, I said that smart contracts run inside a virtual machine. Right? They run inside a node. In the node, there's a virtual machine, which means that there is no external mechanism to directly connect to that, basically. Typically, when you're trying to access a remote system, okay, you will need some form of RPC command, basically, right? Remote procedure call command. Right? Web3.js is a set of libraries, basically, for the application developers, collection of libraries for the application developer to interact with on-chain components with Ethereum. So basically, if you wanted to interact with the smart contract, now the smart contract, like I said, is a program. So assume that the smart contract program has got many functions. One of the functions could be, get my balance. The other function could be send balance to so and so person if so and so business rule is met, basically. Right? Now you need to be able to kind of interact with it in some form and show what is happening over here. Right? That interaction would require some mechanism for your web program, which is written in HTML, to connect with the smart contract system, basically, and call it. Right? So typically, what happens is that there is a library called Web3.js, and the Web3.js allows you everything that you require to then connect back to the smart contract, right? It provides the JSON RPC binding, basically, that is required because you anyways require a mechanism, an RPC mechanism, and the RPC mechanism over here is provided by by JSON RPC, and you then basis these two use your standard web technologies to connect and show information on the web page, basically. Correct. You might always have some need to kind of show some information and those kind of things. So that information can be made available through the web interface using Web3.js and JSON RPC. So that is what the Web3. And this, if you look at it, is not different from your typical backend applications, right? Your typical backend application has got a front end, a middle layer, and a database. So now looking at it from the right hand side, the ledger is your database because it is actually holding all the transactions and the states, right? Your smart contract is your business logic, your middleware, basically. And then your front end is actually HTML, CSS, JS, React, JS, Angular, whatever you choose to, basically. So if you start looking at it in this perspective, these applications are not different from what typically you've known earlier. But since they are decentralized, they are called DApp. Right? DApp means decentralized application. Decentralized means they are actually executing on all the nodes. It is not just basically in a central server somewhere. And that is the key difference between centralized applications and decentralized applications. A centralized application, if your server goes down, let's say for example, you will have a challenge. In a decentralized network, what happens is that all of these servers are replicas of each other. So one of them goes down, the other can handle the transaction, and when the machine that went down comes up again, it will automatically sync itself up with the rest of the network. And that's how a decentralized network really works, basically, right? So this is about what smart contracts is. I saw a couple of questions flashing on the chat. Unfortunately, I'm not able to kind of see the chat just now. I'll have to put the PPT off. But if you can ask the question, I can answer the question here. We'll pause for a few seconds here. Let me check the chat. Chat window, sorry. Written for every business, is that so? Sir, is sir and Let me just read these questions and answer. What is the difference between Ethereum and smart contract? The difference is that Ethereum is the platform and the smart contract is the execution language, basically. So you write your business logic in smart contracts and execute them on the Ethereum platform. So as I understand, smart contract is needed to be written for every business. Is that so? For every business function that you require, yes. So if you require a particular business function, for which you have got certain business rules, then yes, you will have to write smart contract for that. Basically, you have to design your structure in a manner that you can basically write business rules or for each of the particular domain. Why are Web3 applications built on decentralized network? Why are Web3 applications built on decentralized? I'm afraid I've not understood this question, Arvind. If you can clarify this question further, it will help actually. Why are Web3 applications built on decentralized networks? I'm not sure what you're asking, but we can come to it later and we can answer it basically if you can clarify further, right? Okay. Going back. Fair enough. Can you all see my screen now again? I'm assuming yes and moving ahead. Let's go to the next section. How does a smart contract work? Okay. All right. So this is the flow, right, for the smart contract. When you say I write a smart contract, what actually happens, right? Smart contracts are digital contracts. Okay, they allow multiple parties to enter into electronic agreement. So for example, like I said earlier, let's assume that I'll take the example of the truck coming into a warehouse basically. Let's assume that the contract between me and some supplier is that I want some goods basically. Or let's take the example of pizza. So for example, pizza delivered in 30 minutes. Pizza Hut says that if it is not in 30 minutes, then your money is back, right? Basically. So pizza is delivered in 30 minutes, let's say, right? The contract says that if the pizza is delivered at the 31st minute, then you have to not do the payment. And if it happens before 30 minutes, then you have to do the payment, right? Now this is a contract between me and Pizza Hut, right? Or anybody like Pizza Hut. The smart contract is executed saying that okay, the order was placed at 10 a.m. in the morning. If it reaches by 10:30, then a payment transaction will happen. Payment from my wallet will go into Pizza Hut's wallet. Actually, it arrives at 10:31. I get the pizza, but no transaction happens. No money is going. No tokens are going from my wallet to somebody else's. Right? That's an electronic. That's a smart contract. That's an agreement basically. Right? They are trustless or autonomously. Right? They are trustless. They basically don't believe. On saying that Pizza Hut will call and say, oh, but this happened, that happened, there was a traffic jam, this, that, not accepted, right? It will just autonomously saying that if it arrived at my door at 10:31, I will get the pizza. Pizza Hut will not get the money. End of story. It is completely autonomous. No intermediary. Pizza Hut cannot come and change the time. I cannot come and change the time. Nobody can do anything. Right? They execute on the Ethereum blockchain. They rely on the network of peers to arrive at consensus, basically, right? So everybody has to agree that this is correct, and then basically, it is going to be executed. If in one, so if there's a dispute between, let's say, me and Pizza Hut is not a good example, but there could be potentially, contracts where there is dispute, right? And if a particular value doesn't come in, then that smart contract will not execute because consensus will not. Once written in the language of solidity, the contract is completely deployed on the network. So it basically is written, compiled, and deployed. Once it is deployed, it replicates itself to the network where it starts executing on each of them. Now, there is a concept called gas or a concept called fee, which is important to understand actually. Right? What happens is that because Ethereum is a public blockchain platform, and because anybody can actually do denial of service kind of an attack on the platform. Okay. what Ethereum demands is that for every smart contract that is executed, there is a fee to be paid, basically, right? What does this do? It does two things. First of all, it deters malicious players from trying to bring down the rate. Let's assume that there was no fees to execute the smart contract, right? And if I wrote a malicious program which was kind of running into a loop and hogging the network resources, okay, then nobody can actually do anything because it is a decentralized platform. It will continue working. Basically, the entire network will get jammed. But this cannot be done by a malicious player if for every execution he has to pay some, correct? And that is the whole idea of the fee, basically. But the fee is also used to kind of help maintain the network, because maintaining and running the network is an expensive affair, basically. Right? The fee is charged in V, basically. V is 10 raised to the power minus 9 ETH, basically, which is 1 upon 100,000 ethers, basically. 1 upon a million ethers, basically. So that is the unit of measure, and it is called gas, right? It is called gas price. So you'll often hear the concept of the gas price is very high, the gas price is very high. I'm not executing my contract now because the gas price is very high, basically, right? The gas price is basically depends on the complexity of your contract. However, higher the complexity in your contract, higher the fee. And it also sometimes depends on the network traffic and the congestion in the network traffic. So if there are too many things happening in the network at the same time, if the network is very congested, the fees could be higher. And some people choose to not run their smart contracts at that point of time, run at a later point of time, because at a later point of time the fee will be lesser. So that is the concept of gas. That is the concept of the fee for running a smart contract. So this is typically how a smart contract actually executes or runs. What it is, what it does, how it executes, and what it takes to execute a smart contract on an Ethereum network. All right. Now, here is a short example of a Solidity code, right? And this is a sample code actually I've taken from some other place. But look at the things that are highlighted. So if you look at the first part on the left-hand side top, there is the concept, there is a construct called contract ballot, right? This is the contract definition. So you're defining a contract called ballot. A ballot is a vote, right? This is a voting smart contract. Okay. The next highlighted piece is called struct proposal. So struct proposal says byte 32 name, unit vote count 1, unit vote count, right? Now, this is the structure. This is the state. This is how state is managed, basically. So it is saying that Agnello has casted one vote. Right? Agnello's address will come there, basically. That is the Agnello's public key, basically, to ensure that Agnello doesn't vote again. Or if it is voted again, then it will just not count, really speaking. It counts. Right? So that is the struct. Struct means the data for the voting. And in our struct for data, there are only two elements. That is the identifier for Agnello for the sender of the message, and his count, actually, which is 1. Really speaking, right? The big chunk on the left hand side is a callable function. So I spoke earlier, right? What is that you can actually call a function from JSON RPC. So this is that function. Because a smart contract has got functions, you can actually kind of call it. So you can actually prepare a mobile app or a web interface where Agnello can come and he'll initiate the ballot, and basically the ballot will be placed, right? There is another function on the right hand side top, basically. That's a validation condition, right? Now in that function, it says that it requires that the sender is chairperson, right? Where the voter is voted, and the required weight is 0, basically. Right? So these are basically the conditions. I said that there are logic. There is business logic or business conditions. The conditions are defined like this, right? It says require sender dot voted, right? For function vote, it requires that this has to happen, right? So these are validation conditions. So if you look at very high level, a Solidity code, if you've done JavaScript, you'll find that this is not looking different from JavaScript, though there are some differences here and there. on how it executes, how you write and stuff like this. But the idea is that it is kind of similar to JavaScript, and this is written in Solidity. The first line on the left hand side called Pragma Solidity 0.4.1.19 is the version of Solidity that is running, basically, right? Because this version makes it possible for you to find the right compiler on your side, on the EVM side, to kind of compile you, right? So I thought that I'll quickly show you. Well, this is not a hands-on session. It is good to kind of know what are the different parts and chunks of a Solidity. And this is a very simple one. Typically, in the real world, these are very complex. There are many lines of code, but you potentially can play around with a small little code like a hello world application if you are interested in doing and writing using Solidity as an application. All right. So what I'm going to do next is basically, and I'll pause to see if there are questions, but what I want to also do is that since we are speaking of smart contracts and spoken a lot about smart contracts on Ethereum, I also wanted you to understand and have the knowledge that there are smart contracts on other platforms also, right? So we'll get into that, but I'll wait to see if there are any questions just now. Let me move on then basically and see whether we can try and finish this in time. Right? A few platforms that support smart contracts. Bitcoin, I spoke to you earlier. It has got limited capability, but there is a concept of script basically running, and we can call that smart contracts. You cannot run very complicated complex smart contracts on this, but you can do basic instruction execution on this. Right? There is a platform called Cardano. Okay. You can develop smart contracts here through something called Vitis. This is a Haskell-based language. Haskell is a functional programming language. Cardano basically is a blockchain platform. Is a blockchain platform which allows multiple blockchain platforms to interoperate with each other. Right? US is another platform again based on Ethereum concept. It supports contracts written using Solidity language. So if you wrote a Solidity contract on Ethereum, then you can actually use it here also. Hyperledger contract can be coded using Java, Go, JavaScript, and then deployed as chain code. Hyperledger, like I spoke earlier, is basically a private or an enterprise platform, if I may say. Right? Corda is another private or an enterprise platform. It also supports the concept of smart contracts. You can write smart contracts using Java, okay, as your programming languages. Right? Solana is another platform. Okay, here the smart contract is written in a language called Rust, a Rust programming language. It is a new language and it is specifically created for smart contracts, and Solana uses that part. Binance provides smart chain solution, which provides full programmability of smart contracts and can be coded with Solidity. I'll talk about Binance a little later. Binance, Hyperledger, and Corda a little later. Right? But the idea is that there are many such platforms which provide smart contracts today, and there are about 1,500 blockchain platforms. Just for your knowledge, all in various shapes and forms. They all try to meet a particular requirement. For like I spoke about Cardano basically, which is allowing interoperability, or Hyperledger, which is for private blockchains, which Bitcoin, which is for standard transactions, but allows some capability of scripting. Right. So let's talk about smart contract concept in Hyperledger. Right. Now, see, you understand that, more than Ethereum, Hyperledger requires smart contracts because Hyperledger is to be used in a business environment, in a private enterprise space, right? And that is why it is important that they also have this concept of smart contract. So just like Ethereum, Hyperledger provides smart contract system on its ledger. We've probably been, you've heard about smart contracts, chain code, or you have not heard. But smart contract and chain code is being used interchangeably in the industry basically for some reason. But in reality, that is not completely correct, right? Because in Hyperledger, there are two distinct components. There is the smart contract code that you actually write, which is for developers. Okay? This is where you code your business logic. You can use Golang, or you can use Java to write your code over here, or even JavaScript. Chain code, on the other hand, is a packaging mechanism. It is used by administrators largely, not by developers. So what they do is that once you've written a set of contracts, right, then those contracts are clubbed together, and those contracts together are then compiled on the ledger as chain. So that is a packaging mechanism, but it is good to know. It is okay to call smart contracts chain code. There is no problem. Everybody calls it, but knowing the detail of why it is that way and what are these two things is really important, actually, right? So this is what Hyperledger provides today for you as a as a development platform, and you can write business applications. Smart Hyperledger is largely used, very largely used for supply chain based solutions basically, and there are several applications today which implement supply chain and logistics solutions using Hyperledger platform. Okay. Corda is basically by a company called R3. Corda is the ledger. It is a distributed ledger technology. Corda's structure of smart contract is slightly different. Like I said, right, each platform will have a different mechanism. The end goal is the same. The end goal is to provide a mechanism by which business logic can be executed on the blockchain platform, right? Basis which data can be actually written, states can be managed. So that is the whole idea. Right? So as far as Corda is concerned, right, there are three distinct components over here. There is the contract state. This is where the data is held basically. There is the contract file. This is where the rules are defined and the functions are defined. And there is a transaction flow which then ties the contract state and the contract functions on top of it, because the functions typically will work on the state, right? So what it does is the transaction flow, you can define a declarative mechanism to say what happens in the flow at what point of time, how does the state change, what function executes when. So they have kind of made it a little more simplified, if I might call it, or maybe complex on how you start looking at it, really speaking. But fundamentally, I find this mechanism a little bit easier, because then it is easy to kind of quickly understand what's happening between the contract and the state, and how is the state changing. That is the whole idea. Development, as I spoke earlier, you can use basically Java or Kotlin, and then the standard Java tools like Gradle can be used for build and deploy on the node basically. So you can write your code in Java or Kotlin. You can create your files and stuff like this. You can execute your Gradle, and then a Gradle execution will pull out all the dependencies, compile the code, and deploy it to the node. That is the whole concept of smart contracts basically. on R3 Corda basically. That is how smart contracts work. Right? 1 second. I'll talk about Binance smart contracts a little later, because it is in the innovation section, or innovation in smart contract section. But let me pause here and see if you had questions on the different ways which smart contracts are provided by different platforms.
Yes, sir. Yes. Yeah, Shiva Prasad here, sir. The thing is, now, according to this explanation, what I observed is, so in the market of cryptocurrency, maybe Ethereum is going to be stay for the last. Why? Because they are giving the gas as a currency for them, and means the cryptocurrency from Ethereum is already using. Whereas when I studied from the books that Bitcoin is going to be stopped by 2140, is that true, sir? Why? Because there are very limited things.
So that's a good question, and we'll deviate a little and talk about this for a few minutes.
Okay, sir. Okay.
So see, all blockchain platforms provide scarcity, in the sense that there is a limit to the number of coins that can be created, right?
Yes, sir.
Not true in the fiat system. In the fiat system, long ago, the fiat currency system was pegged to gold, basically. But it is not pegged to gold anymore, and you can start printing currency. There is no problem.
Yes, sir.
But cryptocurrencies typically have a limit. When they say that Bitcoin will stop in 2140, actually what will happen in 2140 is that 21 million uh, Bitcoins
Bitcoins are going to be generated.
would have got
Yes,
minted. Then, basically.
Yes.
And those 21 million will only be in circulation. No
Yes.
more will get minted anymore, basically.
Yes,
Right?
sir.
And when they say that Bitcoin will stop in 2141, what it really means is that the minting of Bitcoin will stop in 2140. Okay.
Yeah.
But the usage of Bitcoin will continue beyond that, actually.
Yes, sir. Here, my doubt is, say after 2140, if there is no chance of mine, who is going to pay for the miner, sir? Say, for example, now the miner is getting the whatever the money they're getting from the system, say for the mining, they will get the reward from the system only. But after 2140, who is going to pay for them? I mean, from the transactions they're going to deduct, sir?
Yes. So the
Okay,
idea
okay.
the idea is that miners will always not be paid fees. So today miners are paid 12.5 Bitcoins. But it started
Yes,
with
sir.
us being 50 Bitcoins, actually, right? And you see every few years the amount goes half, actually. From
Yes.
became 25.
Yeah, every 4 years it's going to be hard.
Correct. So then so eventually the miners will not get any mining fee, but they will get transaction fees, basically.
Okay, okay, sir.
Today they are getting transaction fees. Okay.
Mhm.
If you want your transaction to get executed faster, you might want to add transaction fee to your transaction. A transaction fee is like a tip, let's say, for example. But if the
Yes, sir.
fee is higher, if the transaction fee is higher, then there is probability that your transaction will get executed faster.
Okay. Yes, sir. It depends.
Alright.
Sure. Thank
So
you very
that
much.
is great. Let me go to the usage of smart contracts and talk about how it is being used, basically. Right? What is the way it is? I spoke earlier about public blockchains and enterprise usage, basically. Right? So enterprise usage is private blockchain, Hyperledger, Corda, other platforms like Quorum, Daml. These are other platforms that are used inside the enterprise. These are permissioned private blockchains. On the left hand side, you have public blockchains. The public blockchains offer a stronger value proposition because in public blockchain, decentralization actually gets used, right? On the enterprise side, since it's a set of people, contracting with each other, the value proposition is not as high, but there is an argument on which is better and which is not. Right? On the public blockchain, like I said, the value is higher because the execution is in a decentralized mode. And in the enterprise side, these are largely centralized. Although there are many validators, it is still a counted set of validators, right? And so while it is not controlled by a single entity, it is to some extent centralized, right? Smart contracts are key to DeFi use cases. I will talk about them a little later. What is listed below. And on the enterprise side, we use existing processes and rules, and to be automated, we can start using enterprise blockchain. Users do not need any membership to be identified on the public blockchain. Enterprise blockchain, only known entities and identified users are allowed because of private and permissioned blockchains. Correct? There are no governing rules or legal framework today for public blockchain, though some of them are coming just now, but largely not there. But in the enterprise, whatever fundamental laws are there of contracting on paper contracts and stuff like this, those will all apply. Right? DeFi protocols are very complex decentralized contracts. I will talk about why it is DeFi. Right? On the enterprise side, your applications you know, can use smart contracts effectively to couple it with, let's say, IoT and those kind of things, and use it more effectively, basically, right? Because IoTs are events basically which when raised some autonomous activity can actually take place. Now look at some of the examples of public blockchain, right? Earning interest, I spoke about this earlier. Margin trading, synthetics, derivatives, exchanges, insurance, borrowing. Now, let me take earning interest and insurance and briefly connect them together and show how it works. Let's assume that I have got 10 bitcoins. I don't want to sell them. I want to hold this till 2041, right? Whatever. My children will inherit what that is, basically, right? But they are just lying there. The price is going up and down, that is fine, but they are just lying there. What can I do? I can put it into an interest-bearing platform like Compound. Actually. So I can say I'm going to deposit my 10 bitcoins with you, right? With the platform. The concept is called staking. I stake my platforms there basically, or I enlist my tokens there. That platform allows, let's say, a person X to take a loan out of it, basically, right? They need loan in Bitcoin, let's say, for example. So they can take a loan. If they take a loan, they have to pay an interest. Correct? Now, if they take a loan and they have to pay an interest, then this smart contract has to be able to kind of enable somebody taking a loan, calculate the interest automatically, debit his wallet, bring it back, credit my wallet for the interest received, basically. Correct? All this is happening automatically. What happens suddenly if a particular borrower does not pay up? What happens to my bitcoins? Right? Are they lost? Yes. In the real world, they are lost because or what if the Compound platform or the platform that is hosting this takes the bitcoins and run away? Will I lose my coins? Yes, I will lose my coins. And that's why there is an insurance component that comes in. There is a company called Nexus Mutual, which will insure my tokens in that platform. So I'll have to pay a premium to that company, to that platform, and they will ensure that if something happens, if it is stolen, if they are lost, they will reimburse me some part of it, basically, right? That is how DeFi works. Now, since this is all working very complex this all working automatically, it is very, very complex to find out how things are working, and that is why these smart contracts are very, very complex. They usually run into many lines of code, actually, right? But these are publicly available. The code is publicly available for you to audit and see what is happening, because it is a trustless environment, and that is why. On the other side, on the enterprise side, you can have supply chain solutions, you can have securitization, you can have mortgage solutions, you can have syndicate loans, you can have insurance, again, basically, right? Supply chain is one of the most popular solutions built on the blockchain platform, at least on the enterprise side. Not that securitization has not been done and exchanges are not happening, but supply chain has got many platforms, and they are quite successful platforms, basically, with successful beta runs, basically, right? That is today the usage of smart contracts in the way we kind of look at it. I'll pause and see if there are questions here before I go to something called innovation in smart contracts. A very interesting topic. I want to talk to you about 3 things over there on how innovation is happening in the smart contract space, over and above the innovation that was done by Ethereum earlier in the process. Okay, let me move on then and talk about something called innovation in smart contracts. So I earlier said that smart contract is one of the innovations on the Ethereum platform that Ethereum brought. It kind of improved the concept that Bitcoin was providing and enabled us to basically write real application code on top of blockchain platforms. I spoke about Binance earlier, basically, right? Now Binance has got a smart contract system. Okay, but what happened earlier is Binance has its own blockchain platform. Correct. It is one of the largest cryptocurrencies, but it basically has its own blockchain platform, and their goal was to improve speed and throughput, basically. Right? That was their primary goal. So because of that, what it did is that they kind of got rid of uh, the gas mechanism, okay, and got in validators. There are no miners over there, right? The idea was to basically help decentralized apps get built on it, or cheaper basically, and also execute faster. However, it did not support smart contracts, and it was very difficult to understand why decentralized apps could be built on Ethereum or on on the Binance chain without a smart, right? But the DeFi system started, ecosystem started, growing, and Binance found it difficult to compete. So what they did is basically they did a smart thing. Along with the chain, they created something called a Binance Smart Chain. Okay, Binance Smart Chain is a fork of Ethereum, basically, right? It is optimized for lower fees and higher transaction throughput. Okay, and what they did is that they started executing solidity contracts on that Binance Smart Chain. So there are two chains running parallel to each other. There is the main chain, which is the ledger itself, basically, which manages the state of the transaction and all the transaction logs. And then the smart chain is only responsible for basically running the smart contract. Okay. And because it was smart contract on the Ethereum system, okay, they didn't have to create a smart contract system again. Because if they had gone to create a smart contract system again, it would have taken them many years to come up with a new smart contract system. Okay. And so now what is happening is that now Binance is coming with something called CDFI. CDFI is centralized decentralized finance. Centralized decentralized finance means basically a large chunk of the platform is centralized through a set of validators. There are no miners, really speaking. There are 21 validators who can validate your transactions, right? But it is decentralized in terms of basically running on a decentralized environment. But there is no public consensus, if I might call it. The consensus arrived between 21 validators who among themselves believe or don't believe that the transaction is correct or not correct. All right. Let me talk about something called DAML, basically. So DAML is a smart contract platform. Okay. What they are doing is that they are actually creating a layer of abstraction on top of smart contracts. So smart contracts itself is a layer of abstraction on the ledger. And on top of the smart contracts, basically, there is another layer which DAML is putting. And what they really are doing is that they are defining their own coding standard. So you write your smart contract using their markup language, and then you compile it to a target environment. So for example, I can write my code in DAML and say I want to compile this for Ethereum. It will then generate Ethereum code and compile Ethereum application and put it on the Ethereum. If I say that, okay, I've written this DAML code, but the same DAML code I want to now deploy on, let's say, Hyperledger. So they will compile it. It has the ability to compile that to the Hyperledger platform. So what they have done is that they have created a virtual machine on top of a virtual machine on top of a virtual machine. So Ethereum is the first virtual machine, right? Smart contracts is Solidity are compiled on Ethereum on the Ethereum virtual machine. Now on top of Ethereum, on top of Solidity, they are saying that they are allowing you a markup language through which you can actually design your smart contracts and write them. Okay, and target them to a environment of your choice. What does this do? This actually takes away a problem of needing multiple people for multiple platforms. Hyperledger is a different mechanism. Coda has a different mechanism. Ethereum has a different mechanism. Solana has a different mechanism. Cardano has a different mechanism. Which means that if you needed to write one smart contract for multiple platforms, you would have to write multiple pieces of code. What DAML allows you to do is basically allow you to write one code and compile it to multiple platforms. The benefit of this obviously is time and resources, but also it is, if it is tested once in DAML, then it is true for everything else. There is the rate of error will go down. Imagine 7 different people trying to code 7 different platforms. Okay, and each of them will implement a different set of error or introduce a different set of error, basically. That will not happen in the DAML environment, and so the testing will be faster, really speaking, and you can start building sturdy. That is what basically. So it provides a high-level programming language, okay, it avoids vendor platform lock-in. Basically, you can decide you can decide that I want to do this on Ethereum. Then later on change your mind and say, oh no, I don't want to do this on Ethereum. I want to do this on Hyperledger. You can very well do it without having to code it again. You just need to basically compile the code to a new target. Basically, that's what they allow today, basically. So they actually allow you portability of code on multiple blockchain platforms, because one of the largest problem on blockchain today is portability and interoperability. Today, code written on one platform is not portable on the other. At the same time, there is no interoperability between platforms. I spoke about Cardano earlier. Cardano is a mechanism that allows you to basically interoperate between multiple platforms. So you can interoperate between an Ethereum network and a Hyperledger network, or a Hyperledger network and a Bitcoin network, and many such. Bitcoin and Litecoin and all this is possible. Okay. The last piece of innovation that we have seen is a low code, no code kind of a solution. Here, typically what is happening is that people are using something called domain specific language, writing the functionality in natural language English, basically, and then taking that natural language English text and converting it into a target environment, whether it is Ethereum, it is Hyperledger, it is Corda, anything basically similar to what Daml does, but here this is targeted towards business users. So what it says is basically you can actually write your functionality as a user story. So you can say, as a user of a house, I want to create a token for so and so, and you can write this in English basically, right? Typically, the user stories that you write in Agile, you can write typical user stories with certain specific grammar that is defined in the DSL, and the DSL basically converts that into a language, and that language is then converted into a target state program basically. So this is targeted and oriented toward business users, those non-technical users who know the. So typical challenge in the IT industry is that the people who know the business logic don't know technology, and the people who know the technology don't typically know the business logic. Correct. So this is a way to basically tie it back, right? We are saying that the business user can define what they want to define. The platform then can generate the code as necessary. All right. So this is about blockchain. This is about smart contracts. This is about the flow. This is about how they work. What are the components of the different types of smart contracts, platforms, and what are some of the innovations that have happened in smart contract? Or these are some of the innovations that are happening just now. These are just happening, right? This particular low code, no code is something that is just now being tested and stuff like this. Daml also just recently came. Binance is about a year old, basically. These are all very, very new innovations. But this is in addition to what has happened earlier, which means it is incremental innovation and the smart contract space. So what I'm going to do next is basically go on to talk about smart contracts and IoT, and then talk about a couple of use cases that I have towards the end of this presentation. Those use cases should give you a good view of how blockchain can potentially be used in the real world. Fair enough? All right. So let's talk about blockchain, IoT, and smart contracts. You must have, heard a lot of people talking about IoT and blockchain solutions, why IoT can be used. But you also have heard about IoT working independently as a centralized solution and those kind of things. You must have potentially also heard that, smart contracts are primary to kind of, do this kind of things. But the idea is I'm going to talk a little bit more about it and draw a conclusion on and drive you towards an understanding of what this means. Okay, so today IoT systems, right? IoT is going on for a very long time. Today, IoT systems are mostly centralized. Okay, and then there is this concern of data integrity. So let's say, for example, if I am running an IoT system for some service, let's say parking meters basically, or anything, right? Uber cars, I don't know what, something, right? and I go and tell my customers that look, basically all the data is kind of being tracked in real time through an IoT device and all this stuff. But eventually, the data that is being tracked by the IoT device is going and sitting in a centralized system, and there is a challenge of data integrity or data manipulation to happen on a centralized server, because the owner of the server is I, right? Because I am solely giving the service. It is in my data center and cloud environment. And if I wanted to do something with it, I could kind of, if there was a conflict, I could easily go and change this data. There are audit systems and all that is fine, but this is not new. It has happened in the past, can happen again for centralized system. Okay. But besides that, there is also a challenge about this system being a single point of failure. What if irrespective of what we try to do and how many backups we want to have, there is a failure in the system sometimes. Right? So that is the other challenge that is got with IoT. Now, blockchain with its features of transparency, trust, immutability, security, privacy can resolve some of these above challenges. All maybe not, but above challenges, yes, some of them, and it could implement more challenges. I'm not saying that blockchain is the silver bullet and this is the solution for everything. I'm not saying that, but the point is that there are specific ways in this that. Okay. Now, identity of devices is another important challenge, right? You basically need to know that this particular device that is sending me data is really an authentic device or not, right? And so identity of a device becomes, in fact, identity is very important, even for us, really speaking, your KYC detects, for example, even for companies, because they are KYC detects. Identity for things is not something that has been spoken earlier. And today we have started with the blockchain environment and the advancements in blockchain. We started thinking about, can a device have an identity? Then the answer is yes. Basically, there is a concept called SSI DID, basically self-sovereign identity or decentralized identity, which believes in providing a unique identity owned by the entity itself, that is me or the company or the thing in the IoT device. Okay. Uh, uh, which is owned by me and which is sovereign in the sense that it can kind of I can prove my identity without having to share a lot of information. Right now, then there is smart contracts. Basically, we spoke about the truck or the pizza coming into my house, the truck coming into the gate. There's an IoT device which tracks basically the truck is entered, and there is a time that is being captured. Okay. How would it be if I could divert or navigate that event that was generated at the gate from the IoT device to a particular smart contract for execution of payment ledger? Correct? This is an example. It is not straightforward. You are doing many things, but potentially a payment transaction can happen. Okay. Or even a non-payment type of a transaction, saying that, okay, this is good to check. Right? This I can do because I have to do some action. It is a particular event has occurred. This event is captured by the IoT device. The IoT device has given me, I trust the IoT device because it is a device that I know, its identity is identified and authenticated. And so I have to do something. So potentially what they're saying is that if the data is channelized from that IoT device, instead of to a centralized database, then instead of database to a smart contract, let's say, for example, then the smart contract can execute rules based on that. Okay, so that is what basically, right, I'm saying. In the next is that you can potentially say that when a particular event happens, the next step in the workflow is automatically executed. It doesn't wait for me to come and say, okay, the goods have been received. Right? It doesn't say that, okay, I received the goods. I don't get a notification when I go to my system and say, okay, the goods have received. This is now all happening automatically because it is a smart contract. It is autonomous in nature, basically, right? And then this could do many other things, right? It basically complicate. It can kind of, like I said, do payment transactions like into non-payment transactions. But not getting into cryptocurrency because there is a concern and complication as far as cryptocurrency is concerned, payments. But there are other ways by which fiat currency payments can be made. But the idea here is that if you had clubbed blockchain, smart contracts, and IoT together, then you could build a pretty much connected digital platform which could automate a lot of the work that today is dependent on a human intervention or on something else. Not to say that we don't need humans to work, but these are mundane tasks that one has to do in his day-to-day life. If they are kind of automated, then we could focus our energies on higher value things. Basically, that is where this whole thought process of blockchain, IoT, and smart contract is coming into the picture. Basically, right? Let me talk to you about some of the challenges that are there in smart contracts, basically, because everything is not hunky-dory in smart contracts, basically. But since we've spoken about smart contracts and now IoT and smart contracts, let me also talk to you about some of the challenges. Basically. One of the challenges, some of the challenges, basically, right, or the key challenges, is vulnerability, the external data sourcing, and the automated nature of smart contracts. Okay. Now, vulnerability is a real threat actually, because if you did a coding error in the smart contract, then the smart contract could be hacked and something else could be created. Has this happened in the past? Yes, it has happened many times. Basically, what is the value of the money gone lost in this? It turns into billions, basically, billions of US dollars, right? So it is a real problem. It is basically, if it is not tested correctly, it can actually lead to a lot of financial loss actually, right? And it has a higher impact in decentralized environment than in a centralized scenario, than in an enterprise scenario. Because in a decentralized scenario, everything is running automatically. In a centralized enterprise scenario, at least there is somebody who's validating the transaction and seeing something is happening and not happening, basically. Plus, it is not publicly open to everybody. In the public network, it is open to, in a decentralized space, it is open to everybody in the public network. And so it is difficult to kind of, it's difficult to kind of control who can kind of hack it. In a centralized environment or an enterprise environment, it can be very easy. The other data is external data sources. Smart contracts are able to pull external data. It cannot go outside and pull data from an IoT device. So there has to be a mechanism to kind of push that data into this. While there are ways to do this today, basically, there is also a challenge. So generally, we use something called oracles. Oracles are a special kind of a node which allow us to basically interact between external data and internal data. Okay, so it will allow me to the oracle will allow me to pull the IoT data at the gate and send it to the smart contract. Before it's sending to the smart contract, it will validate and see whether the data is coming from the right source. Remember, the IoT device has got an identity. Its identity has to get authenticated. So the oracle basically will capture the data, will get the data. It will authenticate whether the device sending the data is authorized to send this data or not, right? And then it will basically, if it is authentic, then it will send that data to the. However, the problem comes when there are many oracles, and these oracles can lead to some amount of centralization because the oracles are not centralized. If you have only one oracle, then the question is, how do you trust that one oracle? So you'll say, I will do two oracles, basically. Okay, so then there are two oracles. Then you need a consensus between these two oracles. Then you need a consensus mechanism. So it is not simple. While there is a mechanism to do this, it is not simple, and that is also a big challenge actually. And plus, there is a lot of enterprise data sitting behind the enterprise network, right? That data cannot be automatically pulled. Basically, there has to be a mechanism of push and pull. So the enterprise has to be able to push it to a public network, and then the oracle has to pick it up, which is again a challenge because enterprises would be very worried to kind of send this data to a public area, right, or to public. Well, you can secure it, create a secure channel, create a private channel between the external source and the internal source. All that is possible, but it requires architecture, it requires investment, it requires effort, it requires testing, which all is just now happening, and will take some time for us to kind of come and say that yes, this is kind of doable, basically. Okay. And then there is this automated nature of a smart contract. Now, what is the problem with the automated nature of the smart contract? Let's take the example of the not pizza. Let's take the example of goods coming through the gate. The goods were supposed to come at 12 noon, before 12 noon. For some reason, it has arrived at 12. How does business work? Business works that the warehouse manager or the supplier picks up the phone, calls out the warehouse manager, and tells the warehouse manager, "It is sorry, there was traffic on the road, but it's only 30 minutes late. Can we just agree to this?" And then it will be done. This is not possible with a smart contract because it is autonomous in nature and it is decentralized. So the idea is basically, even if, let's say, even if you wanted to change it, the challenge is that it is immutable. You cannot change it. So at 12 o'clock, if at 12:30, if the IoT device triggered the event, the smart contract executed and denied the payment, let's say, you cannot now go back and say, look, basically, I want to reverse this transaction. You cannot change it. In your database, you can go and change it, or in your system, you have some supervisor key, you enter the supervisor key and reverse the transaction. All that is not possible as far as blockchain is concerned, as far as smart contracts. And that is a concern to businesses, really, because businesses a lot of time work on faith on each other. And the immutability or the autonomous behavior of the smart contract doesn't help this cause, actually. And that is also one. Now, in addition, there are other challenges, right? There is a whole question about legality of enforcing and enforceability of smart contracts. Okay, right? Now, the problem is there is this concept, there's a discussion going on in the industry, which is talking about code is law, actually. Okay, what it is referring to is that whatever is written in the smart contract is correct. Now, that obviously is a challenge because the court of law has to start accepting that code is law and what is written in code is correct, right? But let's assume that the court of law agrees that they will look at code. Then there is another problem that gets generated. The problem is contracts are written by lawyers, actually, and they don't know technology. Code is written by developers and they don't know the law, or they don't know the legal language, right? So there is going to be an additional overhead, okay, for someone to come and tie this together. So you will need an interpreter now, just like language. Okay, will it get solved after the interpreter comes? Maybe it will, maybe it will. Okay, here is a real problem that can happen. So let's say there is a law, there's a term, and let's take the truck example. The term says that it should come before 12 o'clock. Okay, it should come before 12. Something should come before 12. If the developer goes and says, if time greater than 12, reject. Okay, then the question is that the right statement? Right? Because it is great, it should be greater than equal to, correct? Or if it says time is equal to 12, is that correct? It is not correct. Because there will be a question on this and the court of law will ask a question. So this is a very heated debate going on in the industry on saying that can smart contracts really replace the real world contracts? And I think it is time that we'll answer this question. We cannot answer this question today because there are many pros and many cons of the concept on both sides of the argument. And really speaking, it will require a lot of change in laws and regulations of the law of the land of the law of the land government. And then there has to be change in law across international boundaries. Laws applied in your country could be different than applied in those countries. And businesses can go haywire based on what what is written in that contract and what is written in the smart contract code. And that is also a bigger debate today that is going on. But fundamentally, these are some of the challenges, not this is not a showstopper. Basically, these are challenges which the industry is actually trying to solve at this given point of time, because at some point of time, somewhere we have to all agree that blockchain is something that can get used in a better way for all of us, both from business perspective and from personal perspective, and also from a basically uh, sustainability perspective and a financial perspective. Sustainability is a bigger question also, and that is why the move that Ethereum is making from proof of work to kind of proof of stake is an important milestone, really speaking, because you cannot be doing blockchain and smart contracts on blockchain platforms if on one side you're going to burn energy like anything, basically, right? So really speaking, that is also a question that is being discussed everywhere. Net, what is happening is that blockchain is still at nascent stage, and it is improving every day. In fact, faster than anything else is changing. This is changing, and it is getting better. I think that it is a question about when will we all be satisfied with what it is, and when will the regulators and governments be okay with saying, okay, this is how it should work. So that is the larger picture of blockchain and smart contracts specifically. Not so much of blockchain, because I think so from a blockchain perspective, which works in the public environment as a cryptocurrency platform, that is a different problem to solve. Okay, most governments and central banks are dealing with that. But I think so if blockchain has to be used and smart contract has to be used in business, then these are some of the challenges that we'll have to face. And these are very top challenges, right? There are many other challenges which I think so would require a different discussion, really speaking. And this discussion might not be enough. So with this, what we have done is we've actually gone through everything about smart contracts. And before I jump into the use cases, I want to answer questions. Okay, there are some questions here. Not to mention, most service providers own your data under their items terms of service. 3 seeks to empower users to recapture the create. 3 applications, sometimes referred to as DApps, are built decentralized peer-to-peer networks like Ethereum. Yes, I think so. I think Arvind. Okay, so your question is answered by you, Arvind. Actually, yes, IPFS is interplanetary file system. It's a decentralized file system, which means that typically in a blockchain solution, when we are trying to kind of upload documents, the documents are not stored on chain. They are stored in IPFS, and the hash or the signature of that document is stored in the blockchain. So yes, the IPFS is another important player. But yes, you are right that moving to a peer-to-peer kind of a ecosystem or a peer-to-peer kind of economy is the final goal. How far we'll reach there, or would it be influenced by some policies that the government defines? That remains to be seen. You might also be aware that the governments of multiple countries are working on something called CBDC, which is central bank digital currency, basically, which is a currency to be used as cryptocurrencies can be used today, but used for your day-to-day expenses. It is a stable coin, It will not fluctuate. So those are the questions in the chat window. Any questions on the call?
Yes, sir. Hello.
Okay, go ahead.
Yes, sir. The thing is, when we are talking about the smart contracts, so can we manage a private blockchain with the smart contracts, sir? Do we need anything extra? I mean, extra thing.
So,
I did not get.
private,
Yes,
so
sir.
I'm asking how this works in the private blockchain environment. Is there anything specific extra?
Yes.
So
Yes, yes, sir.
yes. So Hyperledger, as I spoke about earlier, or Corda R3, as I spoke about earlier.
Yes.
R3 is Corda.
Yes.
Right? These are private blockchains, right? These blockchains are used in enterprise. For example, we use these blockchain platforms for our customer applications. Okay, so we've done several things like KYC. There is supply chain financing that we have done. We've done supply chain trade finance. We've done mortgage. Let's say, for example. Now the idea is that you could write smart contracts in the platform's native platform environment. For example, you could use in Corda, you could use Java to write your application. But you'll have to follow the rules of that platform. Similarly, in Hyperledger, like I said, you have a contract file and you have a chain code. Basically, contract file is Java or JavaScript or Golang code that can be written as a program. Okay, and chain code is basically a packager which is used by the administrator. So each platform has its own. It has its own. Structure. For example, if you were wanting to use Solidity, then there is a platform called Quorum, actually, right? Quorum is a blockchain platform which is created out of Ethereum, and Quorum supports smart contracts written in Solidity. The difference is that in Quorum, when you do a transaction, it's a private blockchain platform for enterprises, so there is no concept of fees. There is concept of validators, basically. The concept of proof of work is not there. There's a concept of voting that is there, basically. So that is the difference. But fundamentally, in an enterprise environment, you will use a private blockchain, okay, which has got similar set of functionalities that public blockchains have, except for the absence of cryptocurrencies and the absence of proof of work mining, basically, because proof of work mining kind of energy is not something that enterprises can spend on. Basically, it becomes very expensive.
Yes, sir. That is the biggest challenge. Yes.
Correct. And that challenge is being resolved now for Ethereum, but not for Bitcoin. Bitcoin doesn't have a solution for this at this moment. They've tried several other things, but fundamentally they will have to use proof of work. But that still remains to be seen if somebody comes up with new innovation which can also move Bitcoin to, let's say, proof of stake. But since it is going to work till 21, still mining, because mining is going to happen till 2041. It is kind of important that they kind of mining is still required later on.
That is the reason. Yeah, that is the reason I assume that Ethereum is going to be stand in the market for the long time because they are making use to with the gases.
Correct.
I just wanted to clean gases like that.
And Ethereum besides Ethereum providing proof of stake now, its smart contract smart contract system is very, very strong, which allows the extension of the capability of the platform.
Okay.
So there is a question which says, which blockchain is best for smart contracts? I think Shama, there is no concept as best and not best, actually. The idea is look at what your use case is, basically, and find out which features of which blockchain will be best suited for my. I'll give you an example of what we did. So we do work in Coda, we do work in Quorum, we do work in Hyperledger, Bitcoin, right? Many other platforms, BitChain DB, these multi-chain. Right? Now we wanted to actually create a solution where we wanted to do supply chain financing, a, and innovate supply chain financing instead of kind of doing it at only the top layer, do it at the bottom layer. Just to explain, in a supply chain, there are many suppliers. The way today's supply chain financing works is that it provides finance to suppliers only at the top level, basically. But really, the finance is required by the deep tier suppliers, right? And our solution is innovating to kind of do just that. It is trying to provide incentive to deep tier suppliers so that they can get finance at a cheaper rate. Right? Now, when we wanted to do this, basically, the choice in front of us was Quorum, was R3 Corda, and then there was Hyperledger. Hyperledger, by the way, is the best suited solution as far as supply chain solutions are concerned. The best platform as supply chain solutions are concerned. Okay, Quorum is Ethereum based, basically, right? It provides the concept of tokens inherently, really speaking. Okay, but the challenge with that was that it was owned by another bank, actually. And if we were going to take the solution to, let's say, banks, then we would face challenges in selling that solution to different banks, basically. The third solution, the third platform with was Corda R3, basically, R3 Corda. And that actually provided us a lot of benefit. R3 Corda is specially made for financial applications, basically. Supply chain financing is a financial applications. Corda R3 had the token system, basically, which Hyperledger did not have. Right? And so we then decided that we will use Hyperledger, we will use Corda to build our solution. Right? So it is based on how you want to design your solution. It is based on what is the requirement of your solution, and then based on that you have to choose a platform. There is nothing like best smart contract. If you ask me personally, which is the best smart contract system, then in my view, the best smart contract system is Ethereum. Everything else is a branch of Ethereum, really speaking, right? But can I start using Ethereum for everything else? No, I cannot use. And that is where the whole question is. Okay. The next question is, can you provide some real-time organizations?
Okay, thank you so much, sir.
Yeah, welcome, sir.
Thank you so much, sir, for your valuable information. Thank you.
Can you provide some real-time organizations which is working on private blockchain? Many of them are working. Many banks are working on private blockchains. Basically. To name a few, basically, IBM and Maersk are working on a blockchain solution for supply chain. Right? There is a platform called, there's a system called Contour, who's working with HSBC on a platform, on a blockchain solution. These are organizations, real organizations, basically, which are working. We do work with a lot of our customers, but for reasons of privacy, I cannot name them here. But fundamentally, there are many enterprises who are working with blockchains. So we will through it. I don't know what this means, actually. I think so it's a continuation of your question. Can you explain how we can implement e-voting smart contracts using Ethereum? Yes, basically the idea is very simple. The idea is, you can basically divide, identify that so you first have to create a poll, basically, right, a ballot, saying that this is my ballot. I want to vote against, vote in favor. I want to collect votes for, let's say, should we use Ethereum or Hyperledger? Just giving an example. And then let's say, you set up an Ethereum environment, you write the solidity contract, you onboard all of your users who are going to vote, because onboarding all of these users will require an account on because if you want, let's say 100 members in your college or your campus to vote on this, basically, then all those 100 people need to have an account on Ethereum platform. Okay. And because they have an account on Ethereum platform, they can then basically use their Ethereum account to cast their votes, basically. So typically, basically, you will have a mechanism which says cast vote. You will have basically a mechanism which says initiate the ballot or initiate the poll. You will have a mechanism which says count the votes, and you will have a mechanism called result. Basically. So you'll have at a very high level 4 functions. Right? And then you use solidity to basically write these functions. You create a structure, like I said, the state that you want to manage. So you'll have a structure which says, the individual vote, and you'll have a structure which says the total votes, basically, because you want to have the list of individual votes that were placed, and then you want to have the total votes that were placed against the options, basically. Right? So you'll have another structure which says basically, total votes. In the total votes, you'll have, let's say, 2 or 3 options, basically, and against those, and these 2 or 3 options will be your attributes, and against that attributes, you will basically count the value of votes having come into it, basically. Right? So that is what it will happen. So when somebody votes for a particular option, that particular option is first written to a state where saying that Agnello has voted. That is the first step. The next step is basically go to the other smart contract or the other state and say that option 1 was chosen by Agnello. So you increment option 1's count, basically, and then the state is saved. Right? Speaking, the smart contract executes, the state gets saved. Finally, when everybody has voted, you can just query the result state, basically, where you want this option, and you can display that result state on the page, saying that okay, these are the options, and each option has got these many votes, and that's about it, basically. That is how you will actually build a voting system. All right. Okay. Let's go into actually, I'm not supposed to comment on this, basically, because this is not something we comment on. This is something very personal, and there are several regulation and challenges, basically. So maybe you can get this answer from somebody. There are multiple forums on the net you can get answers. Sorry about it, Arvind. Okay, so let me close the chat window, go to basically use cases. Now let's talk about an IoT based medical supply chain. Right? We've got 15 minutes, and I think this is good enough for us to kind of finish this and have a couple of more questions. Now, one second. So here is a problem statement, basically, right? Temperature sensitive products such as medicines, foods, dairy, distributed by supply chain known as cold chains. Most of your vegetables, milk, for example, dairy products, or medicines and vaccines recently being transferred from one place to the other, they transfer under a concept called cold chains. They are perishable goods, actually, and they need to be maintained at a particular temperature when they're being transferred, basically. Okay. And it is a very complex distribution process. Need constant control, monitoring, documentation, right? And has zero room for error, especially in food items and dairy products and medicines. The challenge that people are trying to handle over here, or the authorities are trying to handle over here, is that the food which is being transferred, or the dairy that is being transferred, if it is not transferred at a particular temperature range, it can go bad, and if it is consumed by people, it can cause health issues to people. Same is true with medicines. It's possible that the medicine can have an ill effect on the patient if the temperature was not maintained in a particular range. Okay, and serious harm can be caused. This can cost life, this can cost money, financial problems, and all those things. Now, the annual total loss on this kind of distribution losses is counted at $34 billion globally, actually. Food getting spoiled, meat getting spoiled, medicines being thrown out, basically. And this is only that can be tracked, in the sense that, which is tracked. So, for example, if vegetable was supposed to be transferred at 8 degrees Celsius and 20 degrees Celsius, and if the temperature hit 22 degrees at some point of time, today there is no way for you to actually find out that this has happened. You will have to depend on what the driver says, or what the hub says from where it has come, or what the post says, basically. Right? Who requires that the temperature sensitive goods be transferred between 2 degrees and 8 degrees Celsius only, basically. Anything outside this range is not acceptable. But if it becomes 1 degree Celsius or becomes 10 degrees Celsius, would you ever know? Will the hospital ever know? Will the Will the medical store ever know that this has happened? Maybe, maybe not. Actually, correct. And so there is a risk of basically this being causing problems. Correct. And it is then necessary that there is a system that we can track, right, and record temperature in a transparent and an immutable fashion. And so what better than blockchain is the response, correct? So let's look at what the solution can. The potential solution can be, a blockchain, because it provides immutability, which means that nobody can go and change the temperature data. If the temperature shot up to 22 or 25 degrees Celsius, like for example, then I cannot, as a database owner, go and change it back to 20. There is transparency because everybody has access to this information now on the ledger, because you are on a distributed ledger technology. Smart contracts basically is the key to all of this, because that is what will drive all these programs basically. And the IoT device is another important player in this basically, because that is what will actually behave as the temperature sensor and record the data and send the data out basically. Okay, so here is a very, very high level architecture of a solution that you potentially can actually use to do this. So on the extreme left, there are various participants. There is the manufacturer, there is the warehouse delivery, there's a freight booking system, there's a sixth driver, there is a buyer user, basically, right? All of them are important. So the buyer is buying something from the manufacturer that is passing through the warehouse driver, through the freight booking system, through the city driver, basically, and a challenge can happen anywhere actually, since there are so many. Typically in a supply chain, the supply chain is so largely distributed that problem can happen anywhere in the system. Correct. So typically what you can do is you can set up a blockchain system. Have the manufacturer, the logistics provider, and the buyer as nodes on the blockchain platform. Have a notary, have a sensor data node that comes in basically, which is held through an oracle, really speaking. And then have IoT devices which connect through, let's say, IoT hub, and capture the information and send this information back to through a DAP into an oracle, which is then stored onto the sensor data node. Correct. What will happen is that every point of data, what will happen is that there is a temperature sensor inside the truck, which is transporting the goods. That transfers sensor data. That sensor is basically capturing the data and sending it to an edge device. Basically. From the edge device, it is coming to cloud, let's say Azure IoT Hub, basically, and from there it is being pushed to the blockchain to make sure that the blockchain gets the right amount of data. Right now, it is indicating that this data is passing through all this. But remember that the data has to be secured in transit also, not only at rest and not only at source. So several things need to be taken care. Basically, you want to be sure that the IoT device that is sending the data is the identified IoT device. That the blockchain platform can identify and authenticate that IoT device. No other IoT. It does not allow the driver to put his own IoT device into the truck basically and send faulty data. It can only be a verified and authenticated IoT device. The data is being transferred through secure through a secure layer, basically through encryption, and then it is coming to the blockchain, and the blockchain then everybody can actually see. On the blockchain there can be a smart contract which goes basically is getting data every 5 minutes, every 30 minutes, whatever that is defined. And what it is doing is that it is already recording all the data, but at the same time it is also basically calculating the average tolerance limit. Basically, for example, the business logic could say out of the 100 readings, if 5 readings are outside the temperature range, then it is okay. If 6 readings are right, then not. So what it does, it continuously managing state from time to time and saying that was the data really coming within the tolerance range and is it valid, and then basically that data can be actually published to all of them, manufacturer, buyer, logistics provider, and basically you can do real-time check on this, on saying that basically consecutively 3 times I've got data which is like above 20 degrees, let's say, for example, or above 8 degrees, let's say, for example, right? then somebody can actually call the truck driver and tell him to check what is wrong. Maybe the thermostat is not working, maybe some temperature is not running. So he can, this all, real-time action is possible while using blockchain smart contracts and IoT in a supply chain for perishable goods. Here we are talking about medical supply basically, and then you have several dApps. These dApps are decentralized apps which can then be accessed through a mobile device or a interface and any other interface if that was required. All right. Any questions on this one? Okay, let me talk about another one, basically a supply chain use case using IoT device. Right? Here is a typical supply chain flow, right? And believe me, this is simplified actually. Okay, so but a real supply chain has got many more players. For example, you see the logistics player over here. The exporter sends something to the logistics player, the first logistics partner over there. Okay. Now, typically the logistics partner also deals with something called TPLs, which is a third-party logistics, because the last mile is not typically covered by the logistics partner. Okay, so that means there is one more player. The same thing can happen from the source. There's a TPL, right? There are several. There is an import custom. There is an export custom. There are multiple custom codes that you will draw. The logistics partner on the other side, multiple banks, right? Now think about ordering a B2B system where you ordered for certain goods and you want to know where your goods are. Correct? In today's world, in this complex environment, it might be difficult for you to point out where it is basically. But by use of IoT sensors, let's say for example, you can very easily send back location of a particular option. Right? You can send location, you can send a tag saying that whether it is on road or on sea or in air, basically. You can say it is it is at the port or it is not at the port. Is it at the export customs or it is at import custom? Has it stopped for fueling somewhere? So this whole mechanism of saying that I have started my import at this point of time. Okay, and it is supposed to come at this point of time. Okay, on the last day you realize that it has not come today, and somebody calls and tells you it is stuck at customs for something else, basically. Right? For example, if the transaction is stuck at customs and if it is stuck there for a long time, a notification can be generated to the respective stakeholder. For example, if it's the export customs, for example, then something is wrong or some document is missing at the export custom. Right? If the notification is sent to the exporter, then the exporter can actually preempt and proactively find out what is wrong and try and resolve that challenge. Right? Same can happen at the import coast. Same can happen at the shipping carrier. The idea is that if you embed multiple IoT sensors into your supply chain, then there is a fine possibility to kind of get an end-to-end. The question really you will ask is it not happening today? For example, your Amazon delivery comes on time because you can track it, right? But Amazon delivery is tracking the last mile. Amazon does not track. You don't get to know until your goods are dispatched. And there could be several days before your goods are dispatched from Amazon. That is because Amazon is dealing with another supply chain system, whereas for which you don't have a visibility, basically, right? So if you want the end-to-end visibility of your system, then you would have to make sure that every step in the process is being kind of tracked and being basically being monitored, and you can get the real-time data information, and you can then be prepared of a delay or not a delay or early arrival. So this is what a supply chain looks like. This is what a supply chain can this supply chain can be improved for visibility by using IoT devices at various places, and obviously See, there are some questions. Yes, actually, what we will do is that after this, we will, somebody will send this slide deck back. Basically, you have my email ID over there and my LinkedIn at the bottom, which you can connect with me with. I have some queries. Okay. All right. So, fine. I think so. Let me wait and see what questions you have about these two use cases. Both trying to deal with different things, but using smart contracts, blockchain, and IoT at the same time. The previous use case was trying to deal with, making sure that goods are being transferred at a particular required temperature. This particular use case talks about traceability or monitoring the supply chain and trying to track where your shipment is at this point of time. Correct? I'm not talking about banks because banks is obviously bank can also get intimated about what is happening where because they have to keep the money ready. But the idea is that in both of these use cases, blockchain and smart contracts and IoT devices are primary solution components, with obviously the additional benefits of blockchain that we can provide. All right then, Dr. Sham, I think that there are no more questions. What we will do is that through to Arijit, we will send this deck out to you, Doctor, and then you can share it with your participants.
So thank you, sir, for your nice talk and giving your valuable time for this session. Am I audible, sir?
Yes.
Okay,
yes,
so
you are.
I finally request the participants if you have any question more. Even you have asked a lot of questions and sir has given all the answers. So I hope that you have learned many things, new things. So this is a new technology. So there are few experts available. So we are privileged to have you, sir, with us. So thank you.
Thank you very much. Thank you for patiently listening to me. I hope I added value. I really think that you have been a great audience. Thank you very much.
Thank you, sir.
Thank you. Bye.
So participants, we have our next session from 12 o'clock. So for this half an hour break, you can leave the meeting, then you join. Next session we have Professor Ashok Kumar Das. Yesterday who has given some lecture on cryptography, electric car cryptography. So today he will give some lecture on blockchain. Thank you.